Hello, this is Dave Free, and welcome to the Fortney and Wygant Safety Update for April 2017. This month we're going to talk about the new regulations regarding crystalline silica. OSHA has spent a number of years putting together final regulations to protect employees who work with silica. What's wrong with this picture? We have a worker who's sawing concrete. He's not wearing a dust mask or respirator. He's not having water applied to the blade to keep the dust down. And this person's going to be doing this on and off all day, breathing silica dust. He can do it 5 days a week for how many weeks, how many years? It's been determined that this is very dangerous to workers. Hazards associated with crystalline silica include silicosis, lung cancer, chronic obstructive pulmonary disease, and kidney disease. These new regulations were put in place so that OSHA can save, by their estimate, 600 lives every year and prevent 900 cases of silicosis. This will be achieved by lowering the permissible exposure limit, or PEL, to 50 micrograms per cubic meter averaged over an 8-hour shift. The old standard was 250 million particles per cubic foot of air. I know it's hard to understand what this really means, so we're going to get into that more. Now I've got your attention. This is the lungs from someone who had very severe silicosis. And in maybe 20-25 years, that guy we saw on the first slide, he might have lungs like this. Who knows? It's really bad. It kills people. This is why there are newer and more stringent regulations regulating workers who work with concrete block, and so on. More on sources of silica. It's found in rock and sand, concrete, cement, mortar and grout, masonry block, brick and tile, granite, sandstone, slate, asphalt that contains stone, and even topsoil. Silica is the second most abundant mineral on the planet. It is found everywhere, and it is very prevalent on work sites. The new OSHA regulation provides 3 ways that an employer can demonstrate that they're protecting their employees from the hazards of airborne crystalline silica. The most preferred method is the use of engineering controls. Engineering controls eliminate the hazard at the source. The employee can go about their work practices without being exposed to crystalline silica. Part of the regulation is a document referred to as Table 1. Table 1 spells out equipment and tasks and how to protect an employee from crystalline silica. And if you follow correctly what the guidelines are in Table 1, you will be considered in compliance with the new standard. And you do not have to worry about overexposure to crystalline silica. You don't have to do any testing. You just follow the rules. The second method is if an employer can come up with performance or objective data that indicates that employees are not being overexposed to crystalline silica. To the best of my knowledge, that type of information is not out there yet or readily available, or anybody's gone about trying to determine when things are safe, depending on different work practices. So that's going to be difficult. The third method is self-monitoring, and a self-monitoring program will be required when you don't have a Table 1 engineering control, or you don't have objective data. Under self-monitoring, they have what is referred to as an action level. The action level is 25 micrograms per cubic meter. You might recall that the permissible exposure limit is 50. The assumption is that once you think you're near 25 micrograms, you have to start self-monitoring, meaning you have to put air testing pumps on employees while they do job functions. and you have to do a sampling. You have to come up with a program to sample it and test it and collect the data and be able to provide it to OSHA, and it indicates that employees are not being overexposed. This is going to be a difficult thing to administer, so I imagine not many people are going to do that. Engineering controls, as I mentioned earlier, are the primary way to eliminate a silica hazard. And when we talk a little bit later about Table 1, which has engineering controls, you'll see that it primarily relies on the use of water or ventilation and work practices to limit the exposure. OSHA Table 1 lists equipment and tasks that have accepted engineering controls and work practice methods. Lastly, with regard to engineering controls, if an employer follows them correctly and they go by the letter of that Table 1, workers will be considered safe and the employer will be considered in compliance. And this is probably the way everybody's, well, for the most part, everybody's going to go on this with this new regulation. This next slide is a list of some of the tasks listed in Table 1. These are the tasks that I pulled off that we'll probably see on our type of construction projects. They include using stationary masonry saws, handheld power saws, walk-behind saws, rig-mounted core saws or drills, handheld and stand-mounted drills, including hammer drills, dowel drilling rigs for concrete, vehicle-mounted drilling rigs for rock and concrete, jackhammers and handheld chipping tools, handheld grinders, and walk-behind milling machines and floor grinders. There are additional tasks and equipment listed in the table, but I thought that these are probably the ones that we'll see mostly on our job sites. Respiratory controls. OSHA Table 1 provides required respiratory protection together with some of the engineering controls that they spell out, only in certain cases for certain pieces of equipment and tasks. When we look at a sample a little bit later, you'll see that they have drawn a line during a normal workday at 4 hours. Tasks worked for less than 4 hours have one standard, and tasks more than 4 hours another standard. When Table 1 requires the use of a respirator, it also spells out an assigned protection factor. This is a NIOSH standard. Typically, the APF is 10. In that case, a NIOSH certified filtering air piece, which is basically a dust mask, a commercial dust mask, will be adequate. When the APF is higher, a fitted respirator with appropriate filters must be used, and that gets into a whole nother level of regulations as far as keeping records and doing testing and keeping medical documents. Lastly, with regard to respiratory controls, if an employee has to wear a respirator for more than 30 days per year, whether it's got the protection factor of 10 or higher, doesn't matter, they're going to need to be offered medical examination and maintenance of medical records. This might be problematic for some employers, but it is required. This next slide is an example of what you'll find in Table 1. The example I pulled out is for a handheld masonry power saw with a blade of any diameter. This is a tool that we see a lot. Masons use it to cut block and brick. It's used frequently on our jobs. In the left-hand column you'll see engineering and work practice control methods. In the center and right column, you will see their protection factor when a person works for less than 4 hours or greater than 4 hours. Okay, so the first thing they say under engineering controls is use saw equipped with integrated water delivery system that continuously feeds water to the blade. Operate and maintain tool in accordance with manufacturer's instructions to minimize dust emissions. If an employer does this, they are considered in compliance. The employee is protected. To go a little further, when the tool is used outdoors for less than 4 hours, the employee does not have to wear a dust mask. If they're going to be sawing for more than 4 hours, they need to wear a dust mask or a mask that has a protection factor of 10. If the same task is being performed indoors or an enclosed area, an area that doesn't have a lot of ventilation, they need to wear a dust mask whenever they're using the tool. This is what employers have to comply with regard to this tool and this task. You'll see this spelled out for 18 or 19 different tools and tasks in Table 1. This is just one example. Just add water. Here you go. Picture of an employee, gas-powered saw cutting a cinder block. You can see the hose leading to the saw. It's applying water at the blade. It's keeping the airborne crystalline silica to a minimum. If the employee performs this task for less than 4 hours a day, they don't need a dust mask. If they perform it for more than 4 hours a day, they do need a dust mask. A little more on alternative exposure control methods that I spoke of earlier. Employers who don't follow Table 1 and they don't have performance data, they have to measure workers' silica exposure if they think it's at 25 micrograms or greater, averaged over a full day shift. They have to protect workers from silica exposures above permissible exposure level of 50 micrograms per cubic meter over an 8-hour shift. They have to start testing at 25. A couple of last points with regard to alternative exposure control methods. Employers in some cases, and it is spelled out in Table 1 in with certain regards to certain equipment and tasks, employers may have to provide additional dust control such as a HEPA vacuum. Also, they may have to provide a respirator program to workers when they are unable to meet the exposure limit requirements. The new standard also recognized that certain work tasks have very low silica exposures. The construction standard does not apply where exposures will remain low under all foreseeable conditions. This includes tasks such as mixing mortar or pouring concrete footers, slab foundations, foundation walls, or removing concrete forms. Additionally, incidental occasions when actions or tools generate silica dust, it doesn't apply. For instance, occasionally if you're drilling a hole in a concrete block or a concrete floor generating very little dust, and this does not cover that or require any engineering or respiratory controls. Contractors affected by the new OSHA silica rules have to be in compliance with a new standard by September 23, 2017. This date was recently changed. Originally it was June 23, 2017, so there has been some pushback on the enforcement, which gives employers more time to get their hands and heads around what they need to do. Further, they have to write a exposure control plan that identifies tasks and methods to protect employees. Also, they must designate a competent person to implement these plans. A little bit more on compliance. When an employer writes a plan, they must include housekeeping practices that expose workers to silica. So someone cleaning up a job site has to be made aware of the hazard of silica and has to be provided protection. You can't use, compressed air to clean out a work site while and blow all the silica up into the air and have somebody breathing it. That's exposure, just like if somebody was doing a work task. Also, as I mentioned earlier, the plan has to provide that employees get medical exams every 3 years if they have to wear a respirator for more than 30 days per year. There's been a lot of information in this presentation. If you have any questions or you want me to do any research on a question, let me know. Call me. I'll help. Also, I'm going to put a document out on Dropbox that contains a summary of this information, and most importantly, the Table 1 that I referred to repeatedly through this presentation. It spells out in detail what employers need to do to protect people. One last thing, thank you very much for watching. Please send me an email or a text that you made it through this and you saw it. I want to keep attendance on who's participating in these presentations. Thank you for your time. Have a safe workday.